Okay, hopefully you took the notes from the front side of the page where we looked at the different things that are displayed on the tiles in the periodic table, and also talked about protons, neutrons, and electrons, which are in an atom. Here's another example little tile from the periodic table. Didn't print right, so I'm just going to draw in the borders there. And what we need to talk about now is, how do you know how many protons, electrons, and neutrons are in an atom of an element based on the information you find in the periodic table? So let's talk about that. So protons are super easy. The atomic number will tell you the number of protons in a single atom of that element. So for instance, if we look down here at carbon, here's carbon's tile on the periodic table. If you remember, the atomic number is the number up at the top, so we know that carbon has 6 protons. Easy peasy. Electrons are easy too. As long as the atom is neutral, the number of electrons and protons are the same. You could also write the word equal if you want to. So because protons are positive and electrons are negative, as long as the atom is neutral, meaning it doesn't have an overall positive or negative charge, that means that the number of protons and electrons have to balance out. So our number of electrons in carbon is also 6. Now, whenever I tell students that, they're always like, how do we know it's going to be, if it's going to be a charged atom or a neutral atom? In my class, you can always assume that the atom is going to be neutral. In high school, you might start looking at things called ions, which are charged particles. I don't think we'll really look at that in our class very much, if at all. If we do, I will make it very clear that we're looking at a charged atom, but overall, you can assume that the atom is neutral if you see it in my class. All right, the last one, neutrons, is the most tricky, but all it involves is rounding and subtracting, and I know that you guys know how to do those things. So, to find your number of neutrons, you're going to take the mass number, and remember the mass number is just looking at this number down here and rounding it to the nearest whole number. Okay, so you're going to take that mass number minus the atomic number. So take this number and round it, and then subtract that number from it. So 12.011 rounded to the nearest whole number is 12. 12 minus 6 is 6. I know, 666, sorry, don't freak out, it's okay. All right, so that's as simple as it is. Look at the atomic number for the first two, and then for the last one, you have to do just a tiny bit of math. Now, there's a show what you know space down here. I want you to solve these and come up and check your answers before you move on to the next thing. One thing I want to warn you about, though, you'll notice that the protons, electrons, and neutrons are all the same in this example, in carbon. That's not always the case. It often will be the case, but not always. So make sure you do the math to figure out your number of neutrons. Again, protons and electrons in this class are always going to be the same, but neutrons sometimes is different. So make sure you're doing the math down here. Don't just assume that all the numbers are going to be the same. Make sure you do that rounding and subtraction. All right, good luck.